Hi, and welcome to Let's Build a Simple Ingest to Cloud Data Warehouse with Low Code. I'm Timothy Spann. I'm a Principal Data Flow Field Engineer, and I'll be covering how you can ingest data into any cloud data store, really, by using Apache NiFi. It's a very simple means to do that. I often do these presentations at my meetup. Right now, everything is global, so you can join virtually. If you can't tune in live, I make sure everything is streamed and recorded to YouTube so you could look at it at whatever time makes sense in your part of the world. We cover a lot of different things from big data, artificial intelligence, streaming, cloud things, microservices, and we take a lot of input from people who attend. And if you'd like to give a talk, just contact us. We usually have spots available. Upcoming, we have one on Flink. We've got some in NiFi, Kafka, lots of different technologies. Really, under the covers, this is pretty straightforward. I bring in some data. For this example, it's a RESTful data. It could be from FTP, it could be from a database, could be logs, could be from sensor devices. Anywhere you have data, NiFi will let me ingest it. Then I'm going to do some routing, transformations, and then I'm going to push it through Kafka so I can take it from my local machine and push that up into my cloud. This cloud happens to be Amazon Web Services, but it could be Azure, could be IBM, Alibaba, whoever it is. Anywhere I could put Kafka, I can either push directly to it through an open secure channel, or I can have Kafka replicate between them with MirrorMaker 2. But we'll do the simple use case. I'm running NiFi locally, pushing up to a cloud Kafka. And then I'm also going to have NiFi store it to a table. This is an Impala table, which is an open source project to let me query my data with SQL very easily. Under the covers, we're storing this in Kudu, which is a NoSQL store that scales really well. Does time series data, that sort of massive amount of data. We're doing version control with the NiFi registry, and we're using Apache Hue to do some analytics. We'll show you a different couple of views of that data as it's coming in to see how valuable that data is and why we wanted to import it. Now, a common use case is I have some legacy database like Oracle or SQL Server, MySQL, MariaDB, PostgreSQL, and I want to get that data out of there. NiFi will pull that in very easily. Often, as part of that, I'll take whatever format that is, whether it's JSON or CSV or text, XML, clean it up, normalize it with a schema, push that into Kafka as Avro, and then I could deliver it to another cloud data warehouse, such as Clouderas, such as open source tools out there, or even just store it in an S3 bucket as a Parquet file, and I could query it with any number of tools later. Pretty easy part of this as well is if I have regular files and I want to load them to a database. Now, if I can do that, there's a couple different ways to do it, but it's one method, and I'll show you that when we hop into the live demo. Put database record puts into a SQL database. Put Kudu puts us into a Kudu store. We'll show you that. Put HBase records put me into the Apache HBase NoSQL database. And Hive streaming gets us into an Apache Hive table. It's one statement. If you wanted to push it to all four of them or to Mongo or somewhere else, you add one more statement or swap one out. Very easy to do. And it's as simple as you set a couple of parameters, and we'll walk through some of those parameters. These can be made external to your data flow. So if you want to reuse them, share them, or have a DevOps tool automatically deploy them and then apply parameters. Say I have it in dev, then it goes to test, goes to production. They may have different URLs, different connections, usernames, passwords, those sort of, maybe even different table names, different schema names. Let's isolate those out with parameters and then push those to it when we deploy. Pretty straightforward. Here is the example using US travel advisories. I'm just pulling in a URL, then pushing it to a MySQL database. Couple of steps. One thing that's really powerful within NiFi, and I think has become extremely useful for developers out there, is because we know what the data looks like. If it's structured, and we're reading it in such as JSON here, but it could be CSV, could be XML, could be a log format that we could parse with Grok. Once I have that in, whether I have a schema stored in a registry somewhere or you let NiFi determine that with inference, I can now do live queries to it. And it's a simple SQL syntax here using Apache Calcite, which is a very powerful engine. So you could do really rich SQL. Here I'm just limiting it by one field, but I could put averages, I could put order bys, I could do a lot. And why that's powerful is I'm doing that import, doing some SQL on it, which could be limit the number of fields, limit the number of rows, any combination that you could do with SQL. And then at the end, I could write it to a different format. So if I wanted to write it right to a Parquet file, I could do a huge amount of processing in one step. And what's nice is this could work on one record at a time, but it could also work on thousands. So if, say, you got a bunch of records came in at once together in a batch of 5,000 records in that 1 second, it could do that. If it's event at a time and there aren't multiple events stacked together or in some kind of cache or unit, that's fine as well. Doesn't make it different other than the number of rows you're going to do at once. Obviously, if I can get 5,000 coming through, say, in like one Kafka message or in one log read, I can push through a lot more data quicker, but it doesn't matter for you when you're developing this. I've got a link in here, so when you get the slides, you can go to an article a friend of mine, Abdulkrim, wrote on how to do some interesting things with these record processors. Now, one other thing you could work with is XML. XML has always been a little bit of a pain to work with. Often it's hard to read, very verbose. It's not the format that modern systems want. Most cloud storage ones don't want XML. People ask me for JSON or Parquet or Avro. Built into NiFi, can pull an XML, convert it into a format people like. Use that SQL in there to do some transformation. Also, I could look at that data and figure out what it should be. And then if I want, I could, match that up against a stored schema that I have. And I could cache it for performance. I have a couple options. Here's some links. One's from my friend Pierre in Paris, and another's by me. Give you some examples if you want to dive deeper into working with XML, which is a common format. Here is just a quick preview of what we're doing in the main part of the app. And there's a bunch of steps here. We'll walk through each one so you get an idea what's going on. But again, this is that same idea. I'm grabbing from a REST endpoint. I'm grabbing a bunch of XML data. Then I want to convert it into JSON. And I'm doing a little SQL on it to limit some of the rows. Very straightforward. NiFi supports SSL. So if you've got something that's an SSL endpoint, that's fine. You see here something interesting if you've read that URL that ends in a .zip. That's a zip file compressed. That's maybe not just one file. So let's get to the demo. I don't think you're here just to see a bunch of slides. Now there is an article describing this. Again, we'll send that out to you if you want another means for looking this up later. But first off, let's start off. This is running on my laptop. It could be running on a 500 node server, could be running in any cloud, but in this part of the application, it's just running on my laptop. So as a data engineer or data scientist, I could just have this running to collect some kind of data that I'm interested in. Maybe also store a local copy so I could run some machine learning on it using my local GPU. So what are we doing? In this case, I'm going to ingest all the weather data for the United States all at once, which is pretty cool. Here, this is what we call a generate flow file. I just use this as a placeholder to get my schedule running. I'm running this every 10 minutes. So that's just triggering off a constant set of requests every 10 minutes. And that's coming into this processor here that invokes HTTP endpoints, which could be REST, they may not be REST. In this case, we're just doing a GET against this web server to get back this zip file. And again, it's SSL. We might have to change these timeouts if things are slow. We could follow redirects. I could put passwords in if I need to go through a proxy. All those sorting settings are available. After it comes to that step, you saw it was a zip file. Let me decompress that. And it knows it's a zip file by looking at it. Now I've got it not shrunk down anymore. It's full size. The next thing I'm going to do is pull out all the individual files. So what's cool about that is that wasn't a zip file of one file. That was a lot of files. And another thing I'm going to show you here that makes NiFi pretty awesome for working with different types of data is what I'm showing you right here. This is built into NiFi. You don't have to set up any special tracing or auditing or logging. This does data provenance. So every time I touch data at every step, it gives me a record here. This can be sent to a database. You can use this programmatically. So if you want to be able to track what you were doing, did the data arrive? When did it arrive? And it includes a lot of metadata. So we called a REST endpoint. So, here's the information on that remote site. This was the URL. We got valid HTTP status. This is when we got it. This is the MIME type. This was the server it was. Those sort of things. And NiFi always adds this UUID. So every time a file comes in, I know its unique ID. So if you need to track it. It also has that entire file, which if I want to view or download, I could do that. Also, if I'm testing and I'm like, I changed something, let me retry it. Boom, I could just hit replay. I don't have to download this expensive file again. Here, if I get a failure, I'm just sending us to this holding place for now. We can programmatically handle any error, or we could just decide to drop it to a file system, send it to Kafka, or just throw it away if it's an error I don't care about. Then the second part, what I'm going to do is I'm going to look at the file name. There's a lot of files that come out of those zip files, and only some of them I care about. I care about ones that start with the letter K, so I'm going to limit it to that. That may seem weird. Why I'm doing that is if we look at some of these files, we look here at a file name, you see here it's got this KQIHXML. The reason why in the United States, airports start with the letter K as their special code, and then they'll have 3, 4, or 5 letters there to identify which airport it is. For me, I just want to know the weather reports at all the airports. Those are usually near cities. That gives me a good subset of data. It's data I care about. This is where people live. It may apply to other data. Say I am selling things. I want to know the weather in those areas. And then this will look familiar. Well, let's dive a little deeper into it. There's that SQL. I'm going to look at that location and make sure it's not unknown. We should have limited that with the K, but not always. Sometimes these are private airports that don't give us any information. I'm not concerned with those. So I'm going to look at XML. This is how I'm going to take XML files that come in and read them. Here it says figure it out. Infer that for me. I could have used a schema that's built into the file, or sometimes I'll have metadata that tells me where to look that schema up, whether that's in an attribute or in a header or encoded in the first line. There's a couple ways to do that. I could have done that and linked it up to a schema registry. I didn't do that. When I'm done, we push it to JSON. So now we're no longer XML, we're JSON. So we have this format that makes sense. We come in, again, some of that metadata, a little more because we've gone further along. Also, I want to show you the data. What was originally XML is now JSON. And as you saw, we didn't write any code. We didn't have to configure anything special. Didn't matter what kind of XML it was. It wasn't from a special place. This is regular XML, came in from this government website, and I download it and I'm using it. And you can see here some of the information tells me where we are. This is an airport in Minnesota in the US. That's the Latin long, the time I got it. And what we really cared about is the weather. So here's all these different weather fields: temperature, wind speed, humidity, those sort of things. And they also have a link to an image that kind of gives you a description of what the weather is. And we'll use that in some of our visualization. So that's nice to have. If you see something weird here is this box is red. Why it's red is I have it stopped. I don't have it enabled. So if you look here, you've got all these records here sitting here. They're not lost. They're waiting to be processed. What's unique with NiFi is I have this ability to configure between each step, not in one place, not just once. Every step while I'm processing things, I could set up these queues. And they have a bunch of different options here. This is one server of NiFi. If it was in top of a whole cluster, it's not going to look any different. So I could have this load balance between them and say, yeah, just round robin these as it comes through. I don't need to compress them. So the records are going to come through and get distributed to all my servers. So if I needed to process this faster, which I don't because this is flying, I could just add another node to my cluster, make sure load balancing is on, and it'll just distribute it evenly among them, or through some strategy you come up with. It can look at one of those attributes, and maybe everything from a certain part of a region goes in one place, or say you're processing global data, everything from this country gets processed on this server. Maybe you keep them together that way. You set whatever makes sense for you. I can also prioritize this data to say, if it has this special attribute, it should jump in front of other data. Now that might be, we have this consistent set of data I'm getting from the weather stations, but say there's special weather alerts that come out. That could be, hey, there's a tornado or some other weather catastrophe coming. I don't care about this, standard data that we get every 15 minutes. I want this alert that says something important is happening. Let me push that through the data faster than another one. You don't have to write any custom code for that. So this is sitting waiting for me to publish this to Kafka. If you've heard of Kafka programming, that's a way to do streaming. Generally, that's pretty complex. But for us, it's not. I'm just going to, remember those parameters we mentioned? I have a parameter here that tells me what server I'm connecting to and the port. That's my Kafka broker. This is the topic that I'm going to send it on. I'll show you what a topic is in Kafka, but that's just a way to know how to segment my data to the people who want to consume it, and I'm producing it here. Again, we have that JSON coming in. I'm writing JSON out. I have some other options. I could have done Avro, whatever makes sense for you. I can make it Parquet. I can put it back to XML or CSV, or I could write some code within the scripting language to do some more processing if I really needed it. So we're just going to keep it JSON. Kafka supports transactions if you need them. That could slow down your coding. I don't need it. If I have a schema, let me pass it along as a header. This is a nice feature of Kafka. So if I need to pass in that schema meta information, I could pass it along. There's a lot of different security parameters I could set. I could set sizing here, bunch of different things. Also, this one's important. We have the client ID, so we have the name of the producer. That's helpful when I'm trying to track down this data. So let's start pushing that data in there. As you see here, it's already pushing through thousands of records that have been sitting there. And we could keep it running or we could stop it. Doesn't affect anything. I've got a way to monitor this data that's getting pushed through Kafka. I've got a UI on my server here. This is Cloudera Streams Messaging Manager. It helps me monitor this. Here I can see the broker. Here's my topic. And I could take a look at this data, maybe look at the last 24 hours, see what data is coming in. And I could see a bunch of data here. I could view one of the records. That looks right, it's JSON. See here, there's a lot of records coming through. And it makes it easy for me to go through this data very straightforward. And as we're going through the data, I can store this somewhere else. I can have a consumer reading this. If we look at this topic, I could see who's producing it. That was that topic name, and who's consuming it. We didn't get to the consumer yet, but we could pop into the consumer. That's right here. This NiFi is running in the cloud. This is reading that message from that URL we saw before, from that topic. It's JSON in, JSON out. This is that name, so I know who the consumer is. So that's important. So if I need to, for this, that it's ready. This one's important if you're a consumer of Kafka messages. If you're just concerned with the ones that just happened, you set this to latest. If I want every record that's possibly in the queue, let me start at the first one that's available. So we do that because I want to get all those records. Once it's running, it doesn't matter, but that first time you start up, it's helpful to have. So we got all that data from the cloud, and then I want to write this to a cloud data warehouse. Now I'm using an Impala data warehouse hosted in Amazon from Cloudera. You could have been using another one. It's just this simple to do it. Put in that URL, put in the name of that table. There's a couple parameters here for inferring the type. I'm choosing an upsert, how many records in a batch, those sort of things, and it's writing the data. Again, we could see that data provenance happening, and I can see, what changed. I got one record, I wrote it out, I could see the content. We'll take a look at the table in a little bit. Also have this here. In case something fails the first time, let me retry it. Maybe the cloud wasn't available. Maybe something was down. Maybe I could just pause it, restart that service, get into it again. It gives you a couple of options. Now, say you didn't want to do Kudu. Maybe you wanted to do a SQL one. Just put database record. If you wanted to send it to Mongo, I could send it as a Mongo record. Pretty much same parameters. Cassandra record. There's a number of places I could store this data without doing any coding. I could send it to another Kafka queue. I could send this to Google's BigQuery table, put it in Druid, Elasticsearch, HBase we mentioned. I could put it directly into one of these file formats that are common in big data. I could push it to Solar. Lots of different places I could send this data very simply without having to change any of the data or write anything special. So right in that step, we've pushed it right to our cloud data warehouse. So really, those steps, I'm done. Ingested data, pushed it into the cloud. I'll show you the table, but I did one other thing. I also wanted to do some messaging, which here is proving to be a lot. We got a lot of messages I pushed in. So I'm going to up these queues because they're waiting. I put a timer in here because if I send too many messages to Slack, Slack doesn't like me sending thousands of messages a second. So one thing we can do here is put it run schedule. That could be here where we just run every 30 seconds, or it could be more complex with a cron schedule. That's up to you. I could decide I want to run on multiple nodes, just one node, a couple things at once. You always have a couple settings here. You always have the option of what do you do next. This is a flow. It's not one or two step process. It is it's a flow of ideas coming through your system. Here, once I sent it to Slack, I don't need to do anything else. Now, I could decide to handle failures in some way. Maybe I send those messages to a file. Maybe I try something else. But I'm just going to end it there. I have a secret URL that lets me connect to Slack. And I also can configure the message that I want to send. So this is a number of fields and I'm pulling out of that record, and I'm formatting them just to be a little cleaner. One thing that NiFi has is the ability to pull out any field from JSON very simply, and it's JSON path, which is a common means of dealing with JSON data. So I have that here, and I'm pulling that data out, and I'm going to use that to make my messages. I already increased the queues, so I don't need to do that. So we'll let that continue running. And I'll show you what's happening over here. It's sending a bunch of messages here. We're doing all the different airports as they come in. I'm getting all this weather information. And I've got a link to the image there. It's showing me where it is, temperature, humidity, those sort of things. It's a little delayed here because I pushed a lot of data through. But it's a good way to communicate what's going on in your system. And you could send it anywhere you want, but this is a good way to do that. So we sent the data to where we wanted to. We also sent it to a notification store. Now, the one thing you'll saw right there is it mentions something about versions. So I've made a couple of changes here. I changed that back pressure threshold. So if I want to send this to version control, update the queue. Now I've pushed that to version control and I have the latest version here. So if someone else wanted it, they can use that. Also, you'll see when I was on that top part, it shows me what's been going on recently. I could see we've pushed through about 30 megs of data, 24,000 records, and it's reading and writing a bunch right now. This is what's happened in the last 5 minutes. Gives you an idea of what we're doing. We still have a lot of messages waiting to get written to our Slack group. So we've got this data in. Can I see it, Tim? You showed it to me in Kafka. We didn't have a schema, but I did make a schema. So if we want to switch to a schema, we could use it. It's in my schema registry. But let's see the table. I'm going to query that table that I pushed it to. Again, it's in Amazon. It is in an Impala table. The underlying storage is Kudu. And you can see all the fields here. I'm just limiting it to some that are in the American state of New Jersey. And I'm sorting it by the time it was observed. We've got the lat long here. What was the temperature? You can see it in Fahrenheit and Celsius. Description of someone who is doing the observation. These observatories are at the airports, and they often have someone involved there to put a little description, or that could be automatically determined by looking at some of these attributes. Yeah, but we're looking at those. We also have another hue screen that's looking at the data and checking out the lat and long, showing it on a map so we could see where these different airports are. I also have one here that's just giving us a little chart with temperature and humidity. So you could do what you want with this data. I'm also doing it here. I have this in another type of report, and I could see all the fields here, and I could see the details. There's a lot of data here, a lot of rows. And then I also have another map here. Again, when you're writing reports, it's nice to be able to see where this data is. So I'll zoom in. As you can see, we have a lot of records. And I'll just pick a random airport here. We could zoom down and see the airport in a map here. And you can see here I got lat long, average temperature, because we've got numerous rows for this one airport because we've been reading this for a couple different days, couple different hours, so we can see how the temperatures changed at different reading points. We also have some link information here. humidity, those sort of things, and I could download the data if I wanted. So we were able to push all that data and get it visualized in the cloud. Didn't write any code. I'll make all these flows available for you. So if you want to try this data, or you could put in some data that makes sense for you. So if you have a REST endpoint, you can configure it here. You can also add dynamic features to this. So say the date changes every time you want to read it. There's a built-in, if you see here, we got the built-in documentation. You could jump to some documentation that helps you if you want to do any custom little scripts here. The expression language is the one I could do in every little field. So if I want to do something like maybe do a substring, I could do a substring. There's a bunch of functions that come in very handy, like escaping out XML. So if I have XML within a field, I could pull it out. Same with HTML and JSON. I could also do some pretty cool searching within the code, some math, some dates. We also have some functions. These come in handy for doing things like, well, what's the IP of the server? Give me a random ID. What's the current thread number? Give me a date so I could build up my own timestamp, and I can go back and forth, do some math on that. So if I want to grab a file from yesterday, I can add this little piece of code in here to make this, now, and add that timestamp to the field. So even though we'd say low code, so you could do a little bit of coding in here where it makes sense. Besides the SQL, like if I wanted to change this SQL, I could add, something else to this. I can add an and to this clause. So if I wanted where location, equals something and just get ones in a certain area, or any other information in there, because I see that data that's coming in, so I could just manually restart this to get more data coming in, and you see the data starting to pile up already. So if I don't know what the data looks like, I can code this on the fly while it's running, since I paused it there. So I can look in here and go, well, what are some fields that I might want to query on? Well, this is location, lat long, pressure. Maybe I only care if the temperature is above a certain temperature. Maybe I don't want to look at every record. Maybe I just care if, the temperature is above 50, something like that. I could just change that on the fly and add a new query. If I want to do more than one query, say I want one with, all locations. So I could just add another query. And now I've got two queries. And that one, maybe I'm just going to put that somewhere. Maybe that one I'm going to store locally for my data scientist wants all the raw data, but he wants it in JSON. It'd be nice if he wanted just the XML, I could just drop that. So I'm going to change that. That's all of them. I don't really want just those data. Now it's going to grab me, all the data is going there. We also have the option here, if I just wanted to save that zip file, I could just say, want to put that in HDFS. When that comes down, also put a copy in HDFS. And I'll just set some parameters and I have that raw file. So you're not limited to one path. You're not limited to just having one copy of the data. This also is not making multiple copies of the data until it needs to be stored. This is doing a pass by reference. So doing this isn't going to slow down your flow. It isn't going to cripple your system. Makes it very flexible there. See, I've got all this data here. If I decide I don't really want that. So what I'm going to do is I could just throw that data away. Goodbye data, because I sent that somewhere else. And delete that. I'm going to get rid of that query because I don't really want it. Restart it. All the data flows through there. I've got that raw data, so if I need that for some other reports, and then I'm sending that to Kafka. You can see the messages coming through, and again, that's just running here, pushing more data through the system, Very straightforward for you to do these weather analytics, but it could have been any data. You didn't see anything mentioning only weather data, only REST data. This is any data from any source with little to no coding, and I just pushed it to a data warehouse. I could add more tables. If I want a table for grabbing current Bitcoin values, I could hit the Bitcoin REST endpoint. I could grab it from a local database. Let me know what you're interested in. Maybe we could do a talk next year on another source of data, or if you've got some local URLs, contact me. We'll tweak one of these, make this interesting for you. But thank you for joining my talk. I am Timothy Spann. You could reach me at my GitHub or at my website. I'm always on Twitter. Thanks for joining my talk. Hopefully you've seen the power of NiFi and why you may want to start using this to populate your cloud data warehouses or any data store that's anywhere, anytime. Well, let's do it. Thanks, guys.